Good morning everyone. Welcome to today's maths class. Today we are going to solve the problems from the exercise 3.3. That is from the chapter Understanding Quadrilaterals. Okay, look at the first problem. Given a parallelogram ABCD, complete each statement along with the definition or property used. Okay, now look at this parallelogram ABCD. Here AC and BD are the diagonals. Okay, here O is the point where the diagonals both intersected at the point O. Okay, now look at the given blanks. In the first one, AD is equal to dash. So what is AD? Here AD is equal to BC. Why? So just let us recall the properties of a parallelogram. In a parallelogram, opposite sides are equal. Okay, now so AD and BC are equal sides, we can write AD is equal to BC. Since, what is the reason? Since in a parallelogram, opposite sides are equal. Okay, so this is the reason for AD is equal to BC. Now look at the diagram again. Now angle DCB, where is angle DCB located? DCB, this is the angle. So this angle will be equal to this angle. Why? Again recall the properties of parallelogram. DCB is equal to DAB, angle DAB. What is the property involved in this? Opposite angles are equal in a parallelogram. So by using this property we can say that angle DCB is equal to angle DAB. Here I have marked with the symbols also. So this angle is equal to this angle. Now look at this. OC is equal to, what is OC? See, look at this. In a diagonal, for example, a parallelogram has two diagonals. They both meet at a point. That point is the midpoint for both the diagonals. Why? Because we have the property that is in a parallelogram, the diagonals bisect each other. That means this part is equal to this part and this part is equal to this part. So from the diagram we can say that from O to C is equal to O to A. That means OC is equal to OA. So we can write OC is equal to OA. The reason is, so the diagonals in a parallelogram symbol we can use, parallelogram bisect each other. So by using this property we can say that OC is equal to OA. And look at the fourth one. What is the angle DAB? Where is the angle DAB? This angle. So let us erase this once again. I will draw. So angle DAB, this angle, and angle CDA. CDA, this angle, these two angles. Okay. So they are just adjacent angles. They are side by side. A and D are the adjacent angles. We know that the adjacent angles in a parallelogram are supplementary. What is going to be supplementary? If the sum of any two angles is 180 degrees, we can call them as supplementary angles. So we can say that measure of angle DAB, this angle, and measure of angle CDA is equal to 180 degrees. Why? Because since adjacent angles in a parallelogram are supplementary. What is going to be supplementary? Whenever the sum of a pair of angles is 180 degrees, we can call them as supplementary angles. As these two angles, angle DAB and CDA, are adjacent, they are just beside each other. So we can call them as supplementary. The adjacent angles, their sum is 180 degrees. Okay. Now look at the second problem. Find the values of the unknowns x, y and z from the following figures. Now look at the first one. Here ABCD is a parallelogram. He has given that it is a parallelogram. Yes, parallelograms. Actually, the figures are parallelograms. So here x and 100, x plus 100 is equal to 180 degrees. Can you say the reason why? Angle B and angle C are adjacent angles. Okay, they are just beside each other. So we can say that the reason is the adjacent angles in a parallelogram are supplementary. What is going to be supplementary? Their sum is 180 degrees. So we can say x is equal to 180 minus 100. Therefore x is equal to 80 degrees. Now we have got the x value. Now look at the y. Okay, y is equal to 100 degrees. Can you say the reason why? Y, 100, they both are opposite to each other. Opposite angles in a parallelogram are equal. So this is the reason for this one. Next, z, to find the value of z, we can say z is equal to x. Why? Z and x both are opposite angles. We can write the same reason. Opposite angles in a parallelogram are equal. But already here we found the angle x value. So z is equal to, z also is equal to 80 degrees. Finally we can write, therefore x is equal to 80 degrees, y is equal to 100 degrees and z is equal to 80 degrees. Okay, so just copy this, we will continue the next problem. Now look at the second part, second problem. Here this is a parallelogram. We need to find x, y and z values. Now first look at x and 50. X plus 50 degrees is equal to 180 degrees. Why? Because these two are adjacent angles. We know that adjacent angles in a parallelogram are supplementary. Okay, so we can find the value of x by sending 50 into RHS. Then we get x is equal to 130 degrees. So you got the x value. Now let us find the y value. Okay, here y is equal to x. Y. Here x and y both are opposite angles of a parallelogram. We know that opposite angles in a parallelogram are equal. So by using this property we can say that y is equal to x, therefore y is equal to, already we know the value of x, so y also 130 degrees. Now how will you find the z value? I will say that, and see, look at this, and z is equal to x. Why? Because they are the corresponding angles. This is a parallelogram, so these two lines are parallel, and this is a transversal. X and z are corresponding angles. You learnt the corresponding angles concept in the earlier class. So x and z are equal since they are corresponding angles. So this implies z is equal to, what is the value of x? X is 130 degrees. So therefore here X value 130, Y value 130 and Z also. All the angles are equal. X is equal to Y is equal to Z is equal to 130 degrees. Okay. Now the third problem from the second Roman. See, here this is a parallelogram. In this parallelogram, we need to find x, y and z values. Here x is equal to 90 degrees. Look at this corner. Here at the point of intersection of the diagonals, this angle is given 90 and this angle is x. They both are vertically opposite angles. So they will be equal. So x is equal to 90 degrees since vertically opposite angles. Okay. Now, in order to find the y value, look at this part of the triangle. Here, x plus y plus 30 is equal to 180 degrees since angle sum property. By using the angle sum property, we can take the sum of these three angles is 180 degrees. We know that the sum of the three angles of a triangle is 180 degrees. So, this implies already we find the x value in the previous step that can be substituted here. 90 plus y plus 30 is equal to 180 degrees. This implies 90 plus 30 is 120 plus y is equal to 180 degrees. Therefore, y is equal to 180 minus 120. We will get 60 degrees. We got the y value also. Therefore, y is equal to 60 degrees. Now we need to find the z value. Now look at this. Here, y and z, they both are, so as per this line, these two are alternate interior angles. So, y is equal to or z is equal to y since alternate interior angles. So, whenever two lines intersected by a transversal, this angle and this angle will be equal since they are alternate interior angles. Z and y are also like that only, observe. So, these two are parallel y as it is a parallelogram. So, this is a transversal, we can see y and z are alternate interior angles. I hope you have learnt about the types of the angles when two lines intersected by transversal in the earlier class. Okay, if you have any doubts, just once you refer it. Okay, otherwise you ask me, I'll explain once again. Now, z is equal to y implies z is equal to, what is the value of y? Y is equal to 60 degrees. Finally, we can write, therefore, x is equal to, what is the x value? 90 degrees. Y is equal to 60 degrees and z is also 60 degrees. Okay, please copy it. Now, from the exercise 3.3, second Roman, fourth one and fifth one, you need to do as homework. Okay, you try to do by yourself, and if you get any doubt, you can ask me, I'll clarify. Now, let us go with the third problem. Can a quadrilateral ABCD be a parallelogram if angle D plus angle B is equal to 180 degrees? Okay, angle D plus angle B is equal to 180 degrees. But see, look at this. What are the angle B and angle D? They both are opposite angles. So, angle B is equal to solution. Angle B is equal to angle D since opposite angles of a parallelogram are equal. So, this implies here angle D plus angle B is 180 degrees given. If angle D is plus angle B is equal to 180, then angle D means we can replace with B. So, they both are equal given. So, that's why we can write angle B plus angle B, 2 times angle B is equal to 180. 180 by 2 is equal to 90. Therefore, angle B is equal to angle D is equal to, so individually angle B is equal to angle D, they both will be 90 degrees. So, it can be happen. Okay. So, yes, it can be a parallelogram. Why? Because a parallelogram in which each angle 90 degrees is a rectangle. So it can be a parallelogram. Now look at the next part of this problem. This is the first one. And now look at the second one. AB is equal to DC is equal to 8. Here AB is equal to DC. They both are 8 and 8. Let us write here. Let us draw the diagram. This one 8, this one 8. And AD 4 centimeters. AD 4 centimeters. And what is the other one? 4.4. Is it possible? Is it a parallelogram? No, clearly no. Why? Because we know that in a parallelogram opposite sides must be equal. This side must be equal with this one must be equal with this one. But 8 and 8 okay. But here 4 and 4.4 they are unequal sides. Okay. In a parallelogram opposite sides never be unequal. No. So answer is no, because in a parallelogram opposite sides are equal, but given that AD is not equal to BC, so it is not a parallelogram. A parallelogram cannot be formed. Now we have one more problem, that is third one. Let us do the third problem here. Okay, now look at this. What is given? Angle A is equal to 70 and angle C is equal to 65. Is it okay? Do you agree? So will you get a parallelogram? See, let us draw a rough figure here. ABCD. VA is equal to 70 and C is equal to 65. Is it a parallelogram? No. Why? Because we know the property that opposite angles in a parallelogram are equal, but A and C are opposite angles, but he has given that they are not equal, so we don't get a parallelogram. In a parallelogram, opposite angles are equal, but given angle A is not equal to angle C, therefore it is not a parallelogram. Okay. Now look at the fourth problem. Draw a rough figure of a quadrilateral that is not a parallelogram but has exactly two opposite angles of equal measure. Okay. So one pair of opposite angles must be equal, but it is not a parallelogram. So let us try. Here I am trying to draw it. Now look at this. Okay. Now so we need to get the opposite angles must be equal. So I'll extend this. Okay, so this is A, B, C and okay, here see, look at this. These two sides are equal and this side are equal, and then this angle will be equal with this angle. Okay, so this is a figure with the one pair of opposite angles are equal. Here B and D, A, B, C, D, D. B and D are equal, the angles are equal, but it is not a parallelogram. What type of quadrilateral it is? Can you tell? It is a kite. Yes, it is a kite. This shape is called a kite. Okay. Now, So by this problem, one more continuation of this problem. So draw a rough figure of a quadrilateral that is not a parallelogram but has exactly two opposite angles of equal measure. Yes, correct only. Okay, this is a kite. By this we have finished 4 problems from this exercise. So let us continue the remaining problems in the next class. Thank you. Have a nice day.